Mm-hmm. All right, and it's going. So we can start with this question. A company collects data from thousands of remote devices by using a RESTful web services application that runs on EC2. The EC2 receives the raw data, transforms the raw data, and data, stores all the data in the S3 bucket. Okay. The number of remote devices will increase into millions soon. The company needs a highly scalable solution that minimizes operational overhead. Highly scalable solution. Remote devices is okay. Which of the following combinations should a solutions architect take to meet these requirements? Choose two. So it's collecting data from thousands of remote devices and running them in situ, and then it's transforming transforms the raw data and storing it. So this is giving extraction, transform, and load for the most part, right? And we typically use ETL tools for that in AWS, and the ETL solution that AWS offers is called AWS Glue. They extract, transform, and load. So you use AWS Glue. Seeing AWS Glue in this option makes me happy. Use AWS Glue to process the raw data in S3. Well, to process the raw data in S3 or into S3, because the data is then stored into, well, just English. Option B says use Route 53 to route traffic. I don't think this is a routing thing. It's not a routing thing. No, it's not a routing. Use more EC2 instances to accommodate the increasing amount of incoming data. Okay, to scale it. Okay, but if it's incoming data like that, there are streaming options that we could go to. Let's see. Send raw data to S3, SQS, queue. Use EC2 instance to process the data. We're already using EC2 instance to process data. Putting it in a queue will kind of ensure that it's not lost, right? And then that the server itself is not overwhelmed. The performance doesn't spike. Um, but does it help us address millions, like scaling to millions? No, I think even this one might help more. But this one has operational overhead. Okay. This other one says Q. Okay, yes. Use Amazon API gateway to send the raw data to Kinesis data stream. Okay. So Kinesis data stream is a good option for this type of situation. Configure Kinesis data firehose to use the data stream as a source to deliver the data to S3. Okay. I think this option makes sense. This option E makes sense.
Thought Kinesis was for real-time data evaluation.
Hmm.
Real-time data
Yes.
analysis, yeah.
So it is. Kinesis is for real time uh, data streaming services, period. So, like, if you want to do any work on the data, you can feed it, you can use Kinesis data stream for that. The good thing here is that it's adding data fire hose. So the data fire hose is conveying the data, right?
What do you mean?
So oh, Yeah, sorry.
Sorry.
Mm. So the Kinesis data file host, once it's configured to use the data stream as a source, it's now going to be delivering that transformed data that we just spoke about here. Send the raw data to Kinesis data stream. So the transformed data now will be carried by fire hose. It will be carried by a fire hose
So
to
is
S3.
that what it transit service? Like, is it transferring the data?
Yeah, you can think of it as that. So all you need is like a source and a delivery point.
Okay.
So, but and it's similar to data stream, but it's not just a source and a destination. Kinesis data stream, you can actually you can do workloads on the incoming data, whereas this one is just a point and send, right? So just like the name says, like a hose, it comes in one end just to go out the other end.
Okay. Makes sense.
Mm.
Makes sense.
Um. So yeah, I think that's what makes sense in this particular one. Glue will transform the data, and then okay, let's see. I think these two because it already says choose two, and these two already give good answers. Yeah, it makes sense because all these other options, this is a route, this is solving routing, this is adding complexity, this is solving for performance and loss of data. So just by elimination, self. So actually, could you
Uh,
please help with this one?
a company needs to retain its AWS CloudTrail logs for 3 years. Company is enforcing CloudTrail across a set of AWS accounts by using AWS organizations from the parent account. The CloudTrail target S3 bucket is configured with S3 versioning enabled, and an S3 lifecycle policy is in place to delete current objects for after 3 years. After the fourth year of use, the S3 bucket, after the fourth year of use of the S3 bucket, the S3 bucket metrics show that the number of objects has continued to rise. However, the new CloudTrail logs that are delivered to the S3 bucket has remained consistent, which will delete the objects that are older than 3 years in the most cost-effective manner. A.
Effective.
Configure the organization's centralized trail to expire objects after 3 years. B. Configure the S3 lifecycle policy to delete previous versions as well as current versions. C. Create an AWS Lambda function to enumerate and delete objects from Amazon S3 that are older than 3 years. D. Configure the parent account as the owner of all the objects that are delivered to the S3 buckets. No.
This one, if you are deleting trails, is not going to affect objects. So this cloud trail will delete trails. It's not going to delete objects. This one makes sense. Lifecycle policy. Once you set the policy, you just leave it to run, and that's what it is. It's just going to execute based on the policy. Lambda function to enumerate and delete objects.
The,
So that
the
means the
browser
lambda function would be checking and he would actually introduce costs that we're trying to avoid. It's possible to do it with Lambda function, but it's not very cost effective because even though it says serverless, it's still going to run on the server. They will hand you a bill. I think this license policy makes sense because it's just a policy you set and then it enacts your policy that I've already set.
It says, well, there's an S3 lifecycle policy in the question. It's in place to delete current objects after 3 years. So they already have a lifecycle policy. To delete versions as well as current
I think it's talking about the previous versions.
Okay.
So because this one is in place to delete current objects after 3 years. So they're having issue with the previous objects. I think it's still kind of the fact that versioning is enabled also tells us that there will be some duplicates.
Yeah.
So this one says configure the parent account as the owner of all objects. That doesn't even address the issue. So I think B makes the most sense, yeah.
Cost-effective manner.
Yeah. Okay, a company has an API that receives real-time data from a fleet of monitoring devices. Okay, the API stores this data in RDS for later analysis. The amount of data that the monitoring devices send to the API fluctuates. During periods of heavy traffic, the API often returns timeout errors. During periods of heavy traffic, the API often returns timeout errors. After an inspection of the logs, the company determines that the database is not capable of processing the volume of write traffic that comes with the API. The volume of write traffic. Okay, write traffic, this is key. A solution architect must minimize the number of connections to the database and must ensure that data is not lost during periods of heavy traffic. So I'm thinking and scaling to increase the size of the DB instance. This is an you need something to take that peak load and duplicate the rise traffic for that peak load. B, modify the DB instance to be a multi-AZ DB instance. This gives availability, but not.
That's not our problem.
That's not a problem. Modify the API to write incoming data to SQS. Incoming data to SQS. Use Lambda function that SQS invokes to write data from queue to database. This sounds long, but might make sense. Let's see this other one. Modify the API to write incoming data to an SNS. No. These two options are similar, but this one says SQS, this one says SNS. SQS makes more sense.
Yes, because they said during periods of heavy traffic, the API timeout errors. So because the traffic is overwhelming the server. But if you have a SQS queue, the data is going to be easily controlled. It's going to be the heavy traffic is not going to affect the server anymore because the SQS queue would permit data one at a time, right? So that's why that. But also the increasing the DB instance is a way to go, but might not be the most effective because that instance might also be overwhelmed.
Mm,
There's,
mm,
there's no, I mean, if another level of traffic hits it, that is
mm.
also, it might also be overwhelmed. So I will probably stick to C.
That makes sense. I mean, from these options, I think C makes the most sense, like you've said. Um, although I don't know why the since is right traffic. Okay, yeah. Let's see. Yeah, C makes 100%. Wow, C made the most sense. Okay, a company manages its own EC2 instances that run MySQL databases. The company is manually managing replication and scaling as demand increases or decreases. The company needs a new solution that simplifies the process of adding or removing compute capacity to or from its database tier as needed.
I recognize this question.
Okay. Hmm.
I was actually torn apart this question, Postgres SQL or Aurora SQL.
Aurora Postgres or Aurora MySQL.
Aurora MySQL or Postgres. I think I went for Postgres in this one, but I didn't know what to do.
You so you came across this. Was that during the exam?
Yeah,
Really?
came across this question.
Okay. Hmm. Okay. So let's see.
And I really want
Um,
the difference
the
between
company
MySQL, Aurora MySQL and Aurora Postgres SQL. Sorry.
experience. I'm not sure.
So
I'm not sure.
existing database is MySQL.
Yes.
Aurora allows MySQL. Yeah, Aurora is for SQL, permits SQL query.
Mm-hmm.
But I don't know what Postgres SQL. So maybe we should do a deep dive into this one a little bit.
That makes sense. I think Postgres from like just I think it's just more advanced in some sense than MySQL. I think, but let me finish reading the question so we can just see which option makes the most sense and then analyze. The company is manually managing replication, and then it wants to know when to add capacity and remove capacity as needed. The solutions the solution must the solution also must offer improved performance, scaling, and reliability with minimal effort from operations. Improve performance. Migrate the databases to Amazon Aurora serverless for Aurora MySQL. Migrate the databases to Amazon Aurora serverless for Aurora PostgreSQL. Combine the databases into one larger MySQL. But this is MySQL. Its own instances that run MySQL.
Is it just
So it's running MySQL databases, like multiple MySQL databases.
Yeah.
I don't think it's possible to migrate that to Postgres, except you extract, transform, then load it into Postgres. Because it might be a different format, if I'm not
Mm,
mistaken.
It makes sense. I always thought it was the same format, SQL.
Mm,
Yeah, that makes sense. It might be different format actually.
but let's see. Combine databases to one large MySQL. Run the larger database, largest instances. Create this auto scaling group. EC2 auto scaling group. if you have serverless, it does the scaling based on demand already. Just like Lambda. Lambda will work when the demand is there.
Mm-hmm.
So if you have dude, I just sent a message saying I'm in the learn pass. If you have a scaling group, that means you need to have like there must be something running at all times. If you have zero in your scaling group will I don't what is 10 times zero? Still zero.
But
So
is
you
there
need
not
to
like
have a
a minimum scaling level that you are supposed to put it at?
yeah, you must have at least one.
Mm-hmm.
You know that time we're setting up auto scaling group. If
How
you
do I
have zero, it
remember?
will not work.
Okay, it's true.
So you have to have at least one. So and that's but it already has databases. It's minimal effort from operations. Serverless gives you minimal efforts, like the most minimal, but which serverless? And I think because it's running MySQL, it should continue on MySQL.
Yeah, no, let's see.
So that just for compatibility. Yes.
Nice. That means I was right in this one.
Yeah, because migrating databases to Aurora serverless provides automated scaling, preparation. Aurora serverless automatically scales. Yep. Because that's serverless. It's just like Lambda, allowing seamless addition or removal of compute capacity as needed. It also offers improved performance, variability, blah, 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 blah. Wait, this is Aurora serverless. It didn't say Aurora, MySQL, or Postgre. Okay. Okay. I think we can insinuate that. Postgre is incorrect because okay. Postgre is incorrect because it suggests migrating to a different database engine. Uh-huh.
Makes sense. So that's you're right. So you guys change the
Hmm.
entire database.
Hmm.
You
And that
guys
would introduce
action
compatibility issues.
transform. Makes sense. Makes sense. Makes sense.
Code modifications.
Okay. You learn every day.
Honestly, good testing. Okay, it
A
carried out.
company is concerned that two NAT instances will no longer be able to support the traffic needed for the company's application. The solutions architect wants to implement a solution that is highly available, fault tolerant, and automatically scalable. What should the solution architect recommend? Remove the two NAT instances, and replace them with two NAT gateways in the same availability zone. Use auto-scaling with the network load balancer for the NAT instance in different availability zones. Remove the two NAT instances and replace them with two NAT gateways in different availability zones. Remove the two NAT instances with spot instances in a different availability zone and deploy a network load balancer. Ooh, so highly available, fault tolerant, and automatically scalable. Auto scalable. Um, I didn't see any. Okay, use auto scaling groups with network load balancers for the NAT gateways. I mean, B.
Hmm. Not instances versus not gateways. The instance, you can think of it as like the server that runs the actual job, and the gateway, you can think of it like the path that it's traversing. It has to traverse this path, this particular node to get somewhere. So the company has two instances, not instances, or we can call them servers, and then are no longer able to support the traffic needs. They want to implement a highly available, so that means more than one, fault tolerant. If one fails, the other one should take over automatically, and it should add to itself automatically. Okay. If you do this, then you don't have fault tolerance because you just have two gateways, and then which instance is going to run. I don't know. I don't know how auto scaling will scale for NAT instances in different ACs. Because if you are deploying, like, auto scaling groups are deployed per AZ.
Oh, really?
Yeah, I think there was one diagram that we were using that day that we did that lab. If you in the diagram you'd see AZ, you see region, right? Then you now see AZ, and then within the AZ you now see the VPC, and then within the VPC you now see like auto scaling groups and different systems that are running. Auto scaling group with network load balancer for the NAT instances. But it makes sense, Sha, but in different availability zones, like, are they saying you implement the auto scaling groups like that's in different availability zones? Instead of, yeah, because that might make sense. Remove the two NAT instances and replace them with two NAT gateways in different availability zones. What's the difference between that and this one?
They're removing the NAT instances and replacing them with gateway, but in the B, they're
okay, in different and in the same. Okay. Yeah. Okay, the NAT gateways are different AZs. It makes sense. But you still need like in an instance now. You still need a NAT instance. Okay, replace two NAT instances with sports instances. In different AZs, deploy network load balancer. I don't think D is part of it.
Yeah.
I think B looks reasonable.
Yeah, me too. Let's see what they want.
Mado. See two instances in different. But then what is like the way I always see this instance is the server itself. So this gateway should be feeding the server. Right, that's where I see it. So if there's no server because you have removed the two servers and have put gateways, what would do the actual work? First instances are a bad thing because they're customer managed or NAT gateways are AWS managed. Oh, are they? That's nice. Nice to know. So in this case, I already know to get rid of that instance. Interesting. So if AWS is managing NAT gateways, that reduces the workload on the customer.
Oh, that makes sense.
Instances are legacy technology. If you're already using a NAT instance, we recommend that you replace the NAT gateway. Okay. Let me see this. NAT gateways are managed by AWS that provide scalable and highly available outbound NAT functionality. Okay. By deploying NAT gateways in different AZs, the company can achieve redundancy. Hmm. Okay. So NAT instances require full management by the customer, while NAT gateways are managed by AWS. Okay.
Interesting.
So then the instance in this case is not necessarily the server. What I'm also learning. Okay.
Okay. What instance?
Like the NAT instance, I shouldn't think of it as a server the same way I think of EC2 instance.
Yeah.
Hmm.
So what is it?
Yes, I can't, if I don't call it an instance, I don't know what to call it. If I don't call it a server, I don't know what to call it for now, really.
Yeah.
But they're essentially saying that like the NAT instance, if you are doing NAT instance, then you are the one that is managing it. Network address translator. If it's NAT gateway, AWS is the one that is managing it.
All right.
So again, but that's
Let's see why the answer is not B.
this one that says here.
Because using auto scaling groups with network load balancers, the recommended approach for NAT instances.
But he's not really saying why it's not recommended. Do you get? Can anybody teach me why B is not recommended? Okay, said option B proposes to use access auto scaling with network load balancers to continue using the existing two NAT instances. However, NAT instances do not support automatic failover without a script. Unlike NAT gateways, we provide this functionality. The naming is what's putting me off. Like, because when I think of like internet gateway, NAT gateway, it's like they're not in the same realm anymore. Additionally, using network load balancers to balance traffic between NAT instances adds more complexity to the solution. Okay, let me coin this. Okay, it says first, NAT instances. They are EC2 instances that handle NAT. Oh, yeah, so they are still instances for private subnet traffic. So this is Quen thinking, and we're seeing its thought process. So now thinking is completed and it's giving its answer. So let's see the thinking a little bit because it's taught a lot. But managing, so the instance, they are like EC2 instances, but specifically for network address translation for private subnet traffic. And they are manually managed by the customer. So why did they not use gateway for this other one if it's managed by them and that's the difference? Let me see if it talks about gateway. Hmm. So if they're in the same AZ, that's a single point of failure. That's what it says there. Auto scaling group with, okay, so this is its explanation for option B. To use an auto scaling group with network load balancers for NAT instances in different AZs. So instead of using NAT gateways, keep using NAT instances with ASG as auto scaling group. That way they can scale out, yes, as needed. But NAT instances require specific setup, like disabling source destination checks and managing the routes. Also, NLB would distribute traffic. Network load balancers distribute traffic to the NAT instances, but even if they are in different AZs, if one AZ fails, the other can take over. However, are still EC2 based. NAT instances are still EC2 based, so there's more management and overhead compared to NAT gateways. So EC2 instances, NAT instances, they have a lot more management and overhead compared to your managed. Like for example, Fargate is a managed service. ECS is a managed service. And the NAT gateway, now I've come to learn, is a managed service, which is just translating it, a network address translator managed by AWS. So they said maybe an option, but this is the best. Okay, seems like a solid choice. Okay. Managed by AWS, automatically distributed across multiple AZs and designed to handle traffic volumes. Okay. Noted, noted, noted. Okay. Okay, Victor, David. Oh, Eddie. Eddie popped in. Hi, Eddie. Good afternoon. Today we're only answering 5 questions because there's a lot of moving parts on our ends, on my end actually. So this is the 5th of the 5 questions I was going to answer today. We'll call it a day. We'll pick it up again tomorrow. Yeah. So we've spent about 40 minutes on this. So we'll meet again tomorrow. All right. Actually, once again, congratulations.
Thanks, bro.
To the next exam. You're right. All right, guys. Have a wonderful, wonderful day.
You too, my guy.
All right, now. Thank you. Let me stop streaming and end.